Hi guys, and welcome to the last lecture for Chapter 1. Today we'll be going over science and sustainability, and particularly we're going to be diving into some of the topics that relate to humans as well as the environment, and how humans are integrated into the environment, and kind of going into depth with some of the topics that we already covered, such as natural resources as well as ecosystem services. So just a quick review about how humans are integrated into the environment. As we've covered in previous lectures, humans depend on a healthy and functioning planet for survival. Human society and human existence as we know it today really wouldn't exist without the natural resources and the ecosystem services that the planet and different ecological systems provide for us. Without them, we simply wouldn't be able to exist as we know it today. And in addition to that, it should be noted that natural systems have been degraded and are continuing to be degraded at alarming rates due to nutrient and plastic pollution, for example, climate change, habitat loss, soil erosion, and species extinction on a massive scale. And as we chip away at these natural systems, we also chip away at their ability to provide natural resources, those provisioning ecosystem services, as well as those regulating and supporting services that we just talked about in the previous lecture. Remember that loss of these ecosystem services and loss of these natural resources have enormous ramifications. If we lose those ecosystem services, some of them are incredibly expensive and difficult to replace, as we talked about in the previous chapter, or others are outright impossible to replace. So it's really important that we maintain these systems in a way that allows us to still reap the benefits of those ecosystem services, if nothing else. Otherwise, there will be some serious ramifications. And there are two major problems when it comes to how we have been chipping away at the Earth's integrity to provide some of these services and these natural resources. The first problem is that there are a lot of us. Human populations became stable around 10,000 years ago, and this was due to two major reasons. The first is the agricultural revolution. And the agricultural revolution is something that is termed for the growth and domestication of crops. It was an event that occurred around 10,000 years ago for prehistoric humans, and basically that was the shift from a hunter-gatherer society over to an agrarian society. And this was important for a few major reasons. First, it reduced foraging time. So, simply because we no longer had to spend enormous amounts of time looking for food or hunting for food, instead we could invest in farms right there on our property or right there in our civilizations, and so it dramatically reduced the amount of time it took to get food. It also increased something called food security. Food security is the knowledge or the availability of clean and nutritious food on a continual basis. So instead of the question of whether we can get food being a random chance of how lucky we were that day in finding food foraging, instead we could regularly count on food because we were growing it. So there was a major shift in food security because food became more readily available and more predictable. And this allowed us to spend time on other things. We no longer had to worry so much about starvation, and instead we could put more energy into the development of new inventions, the building of societies, different political structures, language structures, mathematics, etc. So all of a sudden society began to grow very rapidly simply because we no longer had to worry about getting food. Now, that allowed human societies to stabilize and grow steadily over the last 10,000 years. However, over the last 150 years, as you can see on the right-hand side of this graph, human population exploded. And this was due to something called the Industrial Revolution. Around 1850 to 1880, all of a sudden there was a huge increase in technology. And all of a sudden we were able to mechanize a whole lot of things that had previously relied on manual labor. So there was a huge increase in technology and, in particular, our ability to extract resources and grow food. Now, we're going to dive into this in particular in Chapter 7 when we talk about agriculture and soils. But just for now, now, note that because of this increase in technology, there was a dramatic increase in the availability of food, as well as medicine and sanitation. So we had even more food, so even less of a risk of starvation. There was more medicine and cleaner sanitation. So all of a sudden we are having less deaths due to starvation, less deaths due to disease, and less deaths due to dirt and contamination and preventable illnesses that are related to sanitation. So all of a sudden, birth rates were far, far greater than death rates because mortality had declined as a result of all of these great things. And the downside to that is that populations increase enormously when that happens. We're going to go into population dynamics in Chapter 6, but just note that anytime that birth rates are much greater than death rates, population skyrockets like that J-shaped curve that you see on the right-hand side of your graph. Now, the second problem is, in addition to the fact that we are growing exponentially, we're also pretty wasteful. The growth in resource consumption is a problem, but it's particularly a problem when we talk about ecological footprints, something that we're going to talk about in the next slide. Basically, this comes down to a flaw in classical economics. And classical economics is based on an assumption. If you've ever taken an economics class, this is the first thing you'll learn, is that it's based on the assumption that resources are unlimited. Basically, it's not about how much are left over, it's about how fast we can extract them, how fast we can maintain the supply of resources so that we can capitalize on them for economic gain. This goes back to the supply and demand curves that you may have seen if you've ever taken economics. Now, we know, as we've talked about over and over again in the natural resources section, the ecosystem services section, and even in the introduction to this chapter, that this is not a good assumption. Most resources are either non-renewable, meaning that there is a very finite amount of them, or they're renewable, but they're also exhaustible, meaning that if we extract them faster than they can be replaced, we will ultimately deplete them. So because of this, basically our fundamental economic point of view is at odds with the reality of the resources of our planet, and this leads to major problems. And this also leads to something that we just mentioned, our ecological footprint. Now, this is something you're going to need to know. An ecological footprint is basically the environmental impact of a person, or at the population scale, a population. Basically, this is the area of biologically productive land and water that are needed to supply the resources for one person and dispose or recycle the waste generated by one person. So think about if this is the amount of area of land on Earth that is required to sustain you, given how many resources you use, as well as how much waste you produce. Now, ecological footprints are a really great way to conceptualize how much of the Earth that we are using, and it puts it in perspective just how wasteful a given population is. For example, ecological footprints can be scaled up. If you look at the average ecological footprint of a given person in a country and you multiply it by that population, you get a average ecological footprint for an entire country. And you can see on this graph on the right hand side that there is a dramatic variation in the resource consumption practices of individuals for different countries. Basically, take a minute to consider the difference in ecological footprints, for example, in Canada and the United States versus something like Indonesia. The United States uses about 8 times more resources and relies on 8 times as much area per person as Indonesia. And so these issues are really, really intense when you multiply this up to the population scale. Let's take a look. Basically, consider if everyone lived like we do in the United States. The United States has an average ecological footprint of around 8 hectares per person, right? So there are 7 billion people on the planet approximately. Right now, we're probably reaching closer to 8 billion, but for now, let's focus on 7 billion people times 8 hectares of land. That leads us to an acreage or a total area of 56 billion hectares across the entire world. Now, when we convert over to the imperial system, basically in terms of square miles, that comes out to around 216 square miles if everyone in the world consumed the amount of resources and generated the amount of waste that we do here in the United States. Now, when we look at the actual surface area of the Earth, that comes out to around only 57 million square miles. So there is an enormous discrepancy between how much area we would need if everyone consumed the way we do in the United States versus how much actual area is available. So basically we would need almost 4 Earths to supply the resources and dispose of the waste that we generated if everyone consumed resources and generated waste like the United States. So this is a huge problem because a lot of developing countries, as they get more technologically advanced, increase their resource consumption as well as increase the amount of people in that country. So we're rapidly running out of space when we look at terms of resource extraction as well as waste disposal. And this is going to be a huge problem as we reach the threshold to what Earth can actually sustain. And this boils down essentially to a math problem. And we have a big one here coming up because, as we just mentioned, something's got to give. Either we reduce our population sizes, or we reduce our ecological footprint, or we will eventually completely overshoot the planet's capacity to sustain the number of people on the planet given how many resources that we consume. And that term is called overshoot. Overshoot describes the phenomenon of societies overshooting or overrunning the exhaustible resources or the non-renewable resources and degrading the natural ecosystems faster than they can be replaced. Basically, this is overshooting the capacity of the planet or a given area to sustain a given population. Think of the Earth as a carrying capacity or biocapacity, and that comes out to around 1 Earth, right? As we continue to increase our ecological footprints and we increase the amount of people for which consume a given ecological footprint, we will eventually overshoot the amount of area needed for each person when we look at the amount of area that the Earth can actually supply. So on the right hand side you see kind of a conceptual diagram of what overshoot looks like, and we're approaching it very, very quickly. So this is a problem that we're really going to need to figure out how to tackle in the near future. And this goes into something known as sustainability. Sustainability is a fundamental principle that was designed to guide our philosophy in resource consumption as well as environmental degradation and environmental maintenance as well as conservation practices. Basically, it is a philosophy designed with the intent in mind of responsibly using and conserving resources, as well as preserving the ecological integrity of given ecosystems, so as to ensure that future generations of people, so those are going to be our kids, our grandkids, and our great-grandkids, can also survive as well as thrive in the future. Basically, it is living with the intent with future generations in mind. Basically, this entails shrinking our ecological footprints, lowering our rates of resource consumption, and eventually lowering our rates of population. It also includes, on the waste disposal side, lowering rates of pollution, lowering rates of actual waste that we generate, so increasing recycling and decreasing the rates of disposable single-use plastics, for example, as well as lowering rates of degradation, so lowering rates of habitat loss, so that we maintain those ecosystems which provide the ecosystem services that we fundamentally rely on. Now, this is not easy because it involves changing our ways and changing our practices. And it really comes down to getting creative with how we consume resources as well as how we dispose of waste. And it's part social, part economic, as well as part ecological. There are social hurdles that we're going to need to tackle. Basically, people are pretty set in their ways and they don't like to change if something's easy. There are economic barriers. Basically, sometimes being more ecological friendly can be a little more expensive. But there's also technological and ecological barriers as well. And what the good news is that as technology is improving, it is lowering the cost and lowering the amount of effort required to make those changes. So there are some positive sides to the story. And basically, this also goes back to something known as environmental ethics. Environmental ethics are the application of ethical standards to relationships between humans and non-human entities. And this revolves around questions such as, should we conserve resources for future generations? These people don't exist yet. It's an abstract concept. So why should we really care? They don't exist yet. We're not hurting anyone that currently exists. We're impacting potentially future generations. So this boils down to a hypothetical question. Is it okay to destroy a forest in order to create jobs for people? How many lives are lost from an animal perspective are acceptable when we are looking at the creation of jobs for people? Where do we balance these two concepts that often are fundamentally at odds with one another? Should we drive other species to extinction for our own benefit? How much do we value the sake of an animal for existing on its own right versus how much do we value our own economic benefit? When these fundamental terms are at odds with one another, environmental ethics tends to provide a framework for which we can navigate these tough issues. And so these are things that we're going to be considering over and over again when we look at future chapters. A lot of these questions are going to be hard. A lot of these terms and a lot of these facts that we're going to learn in future classes and future lectures are going to be a little unsettling. It's good to be uncomfortable. These are harsh realities that we're going to be faced in the near future, and part of this class is to sort of dive into some of these hard topics and look at some solutions to these problems. We're going to be confronted with them whether we're ready for them or not, so we might as well prepare ourselves for them. Now, that is everything that we have for Chapter 1. I'm really looking forward to diving into other chapters with you. Next, we'll be talking about ecological systems as well as different cycles and some fundamental basics in matter, chemistry, and physics. I look forward to talking with you about Chapter 2. I'll see you guys then.